Good morning, everyone. My name is Mariana Rocha de Souza. I'm very excited to have you all here. I know it's the first event of the day, 9 a.m., rainy day, beginning of the second week, so thank you so much for being here. So I'm a coral biologist, and I represent the International Coral Reef Society. It's the largest scientific organization focusing on coral reefs and gathering all the scientists working on corals, coral enthusiasts, people doing coral restoration, and I'm very excited to have a panel focusing on corals here today. So our oceans, and particularly coral reefs, are facing many threats. That's why we're here at COP. We all know this. But corals particularly are facing so many threats. Like corals are one of the most threatened ecosystems. When the temperature of the water increases because of climate change, corals bleach and they lose the symbiotic algae that lives inside them and provides them the main source of food. And we have seen the bleaching events like increasing fivefold. Bleaching events have increased fivefold since the 80s. Corals have been dying worldwide. We have lost actually 2/3 of the coral reefs worldwide because of bleaching events. So we know all these things are happening to corals, but amidst these challenges, there is also hope. So around the world, scientists, communities, and young advocates are driving innovative solutions that demonstrate the resilience of our marine ecosystems and the power of collaboration. So today, we're going to hear, we're here not only to share these successful stories, but also to identify what makes them possible. What are common grounds? What made these successful stories possible that can also be applied elsewhere? Our hope is that by celebrating these stories and distilling these lessons, we can inspire you and other communities to also take action. So here is what is going to happen today, what to expect from our panel. We're going to hear from 4 different speakers. They're going to share their stories and their work in ocean and coral conservation. And following their presentations, we're going to have a panel discussion. Finally, we'll open the floor to your questions to ensure we have an interactive session. And then we're going to close with closing remarks by Peter Thompson. So we are very happy to have you all here. We're going to start our first speaker, Dr. Valeria Pizarro, Senior Scientist, Coral Program Manager. She works at the Perry Institute for Marine Science. Valeria, it's with you.
Thank you, and thank you, Mariana, for inviting me today. I'm really pleased to be here. Let's see if this works. So I'm the Coral Manager of the Perry Institute for Marine Science, and I'm going to talk to you about a project or something that we did a couple of years back. And I really appreciate the invitation for today, especially just like success stories, because we have been dealing with a lot of corals dying due to coral bleaching and coral diseases, especially in the Caribbean, and this is a good way to do it. So let's see if I can have the presentation going. Okay, that is, okay. Could you, let's see. Okay, so what I'm gonna talk to you, it's a little, it's really not a strategies that we're having, it's something that we did a couple of years ago. And then if I have the time, I will just end with telling you exactly like what are we doing now that is going to be like more strategies to save corals. So perfect. So I'm going to talk to you about a reef that is called Varadero that is situated in Colombia. Now let's see. Can we pass this? Okay. So I tell you next? Okay, next. So this project was, of course, a collaboration of many scientists, different organizations. Next. And as already Mariana mentioned, reefs are really in danger, and in the Caribbean, it's one of the areas that is more in danger, threatened by many aspects. And as we know, the last assessment that we have for the region, the average coral cover, that is usually what we use to know how reefs are doing, were about 18.6%. But this was in 2014. In the last 10 years, we have lost even more coral. So this average should be lower. And in Colombia, and I'm just going to mention that because what I'm going to talk is a reef in Colombia, it's about 5.4 and 68.2, but that is not the case anymore. Next one. So what we're going to talk about is a reef that is located in Colombia near Cartagena. Cartagena is one of the main ports of Colombia. And it is, as you can see, let's see, here, there is a river that actually comes out into the bay, so the turbidity is very high. Next one. So this is what we call an unusual reef, and it is called like that because usually if you look into the books, reefs don't develop on these kind of waters. They need clear waters with low nutrients concentration. And what we have here, it's an annual average discharge of sediments that is very high. It's about 6 tons of sediments per year. It has a lot of industrial pollution because there is a lot of industry all around, and the sewage waste from Cartagena City. Next. And if you go to the reef, what you have, it's a layer of sediments. It's a murky water for about 2 to 3 meters. And then you jump, and you can have in some places, like the photo that you can see on your right hand, that the visibility is very low. So we have high sedimentation. We have high temperatures. It's very shallow, this reef. We have high nutrient concentration. And this is something that is not usual for reefs. Next one. But it has been in peril because there is a shipping project. So they want to dredge a second shipping channel in the area. And what we want to do is understand a little bit more about this reef so we can save it. Next one. So the other thing that we had until 2014 is this reef was not known to science. So no one knew, and especially by the conditions, that a reef was there. So we have a lot of boat traffic on the area, but no one but the fishermen, of course, knew that the reef existed. And we found it just because I quit. I was a professor. I quit academia. I started to do freelance and consultancy, and I was contracted to move some corals for a highly degraded reef. And what I found was actually not a highly degraded reef, but an amazing reef. Next one. So what we started to do was, okay, let's try to see how is this coral reef in terms of the health. And what we found was that actually the average coral cover is 45.1%. And as you remember, it was in the Caribbean, it's about 10%. So this is the average is higher than the other ones. And in terms of biodiversity, it's as biodiverse as any other Caribbean reef. Next one. So when you go to the reef and you have good visibility, you have a very complex structured reef that is something that you don't find in many reefs around the Caribbean. Next one. You have all the different species. You even have endangered species like the Diadema antillarum, that is the black sea urchin that was almost lost in the 80s. Next one. And you have other endangered species like the elkhorn coral. What we have been doing in the last 10 years is just advertising Varadero, so we can just let everyone, including government, that this reef is actually there, because it is not in any of our atlas of coral reefs for Colombia. So we have talked with journalists, we have gone to TV, national TV, we have a Wikipedia page, everything. Next one. We created, of course, a group that is called Salvemos Varadero, Saving Varadero, with people from different professions. Next one. And we, of course, have a web page because this is something necessary. Next one. We have reached everyone, even Yahoo, so we have been in different platforms online just trying to talk about that. Next one. And the best thing is we actually apply and got Varadero as one of the home places of Sylvia Earle. So right now it's actually more like, it's well known, and we have been able to stop the project of the dredging. Next one. So one of the things, I'm going to finish because, of course, I'm going to talk to you about what we have been doing since then, is we've been doing metagenomics on the project. We're looking into the coral productivity. We're looking to understand how this reef, in these conditions that it shouldn't be there, how these corals and these reefs are found, how are they surviving, how they have been just growing so much. And what we have found actually is the conditions that they have, it's like all these sediments and all these nutrients, they come in a way that they are available for the corals. So they're actually feeding on these sediments. The other thing that we have found is the change of this sedimentation gave them a sensation of, instead of 1 day, 2 days, so they're reproducing more often than the other corals. So there is a lot of things, and that's why it's a good thing and a hope for us. And thank you for everything.
Thank you so much, Valeria. It's inspiring to know there are some reefs that are doing good. So our next speaker is Dr. Raquel Peixoto. She's an associate professor at KAUST and a leading member of the International Coral Reef Society. Over to you, Raquel.
Thank you, Mariana. Thank you, everyone. So I also have to say next, right? Today I'll talk a little bit about the project that we've been developing at KAUST in a pilot scale, where we are testing the use of probiotics to protect corals against different types of stress. So next one. And just as background information, not only corals, but all of us rely on our associated microbiome. So we rely on our microbes to produce nutrients for us, to protect us against disease, to mitigate toxic compounds, and corals are not different. But next one. What happens when corals and any other organisms are exposed to stress is that these beneficial microbes that we and corals depend on, they are replaced by pathogens. And this is happening right now all over the globe, not only in coral reefs, but in other degraded ecosystems. And corals and coral reefs, they have an increased abundance of pathogens. The problem is that these pathogens, they are not only pathogens for corals, they can be pathogens for the other organisms in the reef. For example, they can be pathogens for fish, and some of us eat fish. So this is a chain that turns into one disease, because we've been talking about one health when things are balanced, but this is also about one disease when things are not balanced. So sick corals, degraded corals, have an increase in the abundance of pathogens. These pathogens spread and they affect other organisms in the reef, and they can affect humans and other ecosystems as well. So, but the good thing about these as well is that these microbes these changes are very dynamic. So we can also manipulate it back. So we can restore. We can isolate the beneficial ones that are being replaced by pathogens, and we can apply them back, which is what we do for humans, which is what we've been doing for agriculture systems for decades, which is what people are doing now for bees, for frogs, for other threatened wildlife, and we are doing for corals. So we go to the reef, we isolate the good bacteria, we save them in the lab. When the bleaching or the thermostress starts and these microbes start to die and be replaced by pathogens, we go back, we apply them back at high amounts during the heat wave, and we've been managing to keep them alive. So next one. We did this in the lab several times. We've got very good results. It's a video. Can you go next? Yeah. So we tested this in the lab several times, different species, different combinations, several years, 10 years, 12 years studying it in the lab, knowing the mechanisms. And we only got good results. So we decided to do this in the reef at a pilot scale, very well-controlled experiment in KAUST. So we first established the Coral Probiotics Village, is an underwater city where we are doing these experiments. And we started this in a very well-controlled way, inoculating it with syringes. So we knew exactly which corals were being inoculated, and we monitored everything in the reef, not only the corals, but the sponges, the fish, the other organisms, the sediment, the water. And we wanted to see how corals and these other organisms responded to stress. So we ran this experiment, and to probiotics. We ran these experiments, some of them for 2 years, to try to understand all the ecological outcomes. Although in the real world, if you have to use this for stress, you only have to use it for 4 of 8 weeks. But we wanted to see the long-term application to understand the ecology of it. And we've been doing this for a while now. Next one. And in the meantime, we are also in parallel developing ways to scale this up, because of course we cannot go with syringes and apply this on corals. So next one, because it's a video too. So we developed some automated dispensers. This is also well controlled and therefore focused in one colony, but we have these hoses. You know, our irrigation systems in our backyards, this is the same, but working underwater, we have containers with the probiotics. We have the hoses that can automatically dispense this for weeks underwater. Next one, please. And we have some beads that immobilize bacteria, and this is used a lot for bioremediation in the ocean, but also for agricultural fields, where you have these microbes immobilized in a pill. It's like a nicotine patch that you attach to your skin and slowly release the compounds. These bacterial pills, they slowly release bacteria for a month. So you can only go there once, put these beads in a device or in bags around the reef. They will be protecting and restoring the microbiome for a month, and you don't have to go back. Next one. So we've been doing all of this for a while, and last year we had the first heat wave, the record heat wave in the Red Sea. It was a terrible heat wave, 22-degree heating weeks, and we've managed to see good results in the corals. This one is a separate experiment where we only inoculated the corals during the period of stress. When the stress started and we saw the corals were paling, we went there. We applied probiotics with the dispenser, the automated dispenser, during the bleaching event, and we saw protection. We saw enhancement in coral health. We saw that visually, and we also used some metrics that we are still studying now to understand all of the different things that corals improved in the microbiome. Next one. But we are also doing these for other things, for example, to accelerate coral growth. And we've managed to have very good results, increased in the growth of corals, accelerating this for nurseries so we can buy time and save money for restoration efforts. Next one. And we also saw improvements in outplantings. This is a bottleneck when we are restoring coral reefs, the first weeks when we outplant or when you start using the fragments, for example, in Mars stars. You have a high level of mortality, and we had, we only applied probiotics 6 times during the first days of fragmentation, and we had very good results, although we didn't even optimize it for this approach. We only tested this, and there are lots of optimization that can still be done. Next one. And the most interesting thing is that while we were doing this, and especially for the 2 years experiment, we are doing a risk assessment to look at the entire reef and the ecological outcomes of using these probiotics. So we are testing all of the other organisms, and so far we only saw good results. For example, for fish, we had a replacement and a restructuring of the microbiome of the fish living inside corals that are being applied with treated with probiotics, and we had a decrease in the amount of pathogens in the skin of the fish and the gut, and an increase in the number and abundance of bacteria that are actually used as probiotics for fish aquaculture. So we have an improvement in the microbiome of the reef overall, only healthy organisms. And the most interesting part of it, next one, is that when we have mini arms, you know, these arms that we use to look at the crypto biome of the coral reefs, and so we have like a microcosm of the diversity. We had some mini arms that were a half meter or a meter away from corals that we were treating with probiotics. And during the experiment, during the 2 years, we didn't see any difference in the diversity of these arms nearby coral reefs, corals inoculated with probiotics. But last year, after the heat wave, when you looked at the diversity of these arms, we saw that we had 80% mortality in arms that were nearby corals treated with placebo. So it was a terrible heat wave, and we had a lot of mortality. But when we looked at the arms close to corals inoculated with probiotics, we only had 40%, so half of the mortality. And that was impressive because we were not developing probiotics for these organisms. But think about the pathogens that are growing and spreading when corals are sick. I think we managed to kind of block it a little bit or improve the health of these other organisms as well. And this was not even optimized again, and we can make it even better. So this was very good result because on top of not being harmful or causing any harm to anyone in the reef, we are actually protecting other organisms as well. Next one. And we are expanding, we are developing other types of therapies, like even vaccine, if you will. Corals don't have adaptive immune system, but we are priming corals with pathogens and protecting them against infection and therefore disease. And also developing probiotics for other marine organisms like mangroves and seagrass. Next one. And in the meantime, we are also working very hard to bring awareness and to also give stakeholders some tools for them to regulate these new types of strategies, because this is something that sometimes scares people. Oh, you're using bacteria in the reef. Well, the reef is full of bacteria. It has tons of bacteria, but there are good bacteria and bad bacteria, and we are allowing the bad one to replace and grow, overgrow the good one. So they also need to be restored, as corals need to be restored. And we are working with several different societies, microbiology societies. Last week we had the publication of a call to action in 14 different scientific journals at the same time, and we give the stakeholders hope and a framework very similar to what we had for COVID. So during COVID, we developed a framework to accelerate science and deployment, not only the development of science. We can do the same for climate change, and we have a kind of a recipe for that's being discussed during this event. And next one. And this is it, I think. Next one. Just to summarize, we need every single tool that we have in the toolbox, and probiotics is one of them, but of course we need the integrative restoration that can actually help reefs using different types of tools combined. And thank you very much.
Thank you very much, Raquel. Our next speaker is Joe Najera. He's a climate change youth advisory group. He's from the Climate Change Youth Advisory Group in the Ministry for the Environment, Manatumo Tetayano. Welcome.
Let's just lift this up a little bit. Nisan Bolivinaka, everyone. Good morning. Warm Pacific greetings to you all on this very rainy morning we're having today. So my name is Joape. I'm from the beautiful islands of Fiji, from a village in Molevu, Vanombalavulao, and the Lau Archipelago. I'm a youth delegate with the incredible Global Center for Climate Mobility family. Currently, I'm based in New Zealand and part of the Ministry for Environment's Climate Change Youth Advisory Group. Thank you, Mariana, for this opportunity to share this space with you all. New Zealand, a nation surrounded by the vast expanse of the Pacific Ocean, has a deep-rooted connection to the sea. Our oceans are not just the source of food and livelihood, they're integral to our identity, our cultures, and our way of life. For us in the Pacific, the ocean is our lifeline. It's our heritage and our future. It's within this context that the role of youth in ocean conservation becomes even more critical. Today, I want to highlight the growing wave of young ocean advocates across New Zealand and the Pacific from my work with the Ministry for Environment's Climate Change Youth Advisory Group, not only as the inheritors of our planet's future, but active participants in shaping it. We're living in a time when young people are stepping up like never before. In New Zealand, youth-led initiatives have been instrumental in driving change. For example, the Young Ocean Explorers program, spearheaded by Riley Hathaway, has transformed school programs that have reached over 300,000 students, educating them on the beauty and fragility of our oceans and corals, and demonstrating how empowering young people with knowledge can spark a lifetime of environmental stewardship. As a member of the Pacific Climate Warriors myself, a youth-led grassroots movement that has tirelessly advocated for the protection of our seas against deep sea mining, overfishing, and climate change, we use traditional knowledge and storytelling to bring awareness to the issues threatening our islands. In my experience, the most critical factor is community engagement. When young people are given a platform to connect with our communities, we bring fresh perspectives, creativity, and energy. At the Ministry for Environment's Youth Advisory Group, we have seen the impact of this firsthand. Earlier this year, our group successfully lobbied for increased funding for marine protection, initiatives that include Indigenous and youth voices in the decision-making process. This success was due to extensive community connections and consultations where we engaged with local iwi or Indigenous Māori tribes, youth organizations in our regions, and environmental groups, ensuring that the solutions we proposed were grounded in local needs and knowledge. However, scaling conservation projects is often challenging, especially when resources are very, very limited. Co-innovation and collaboration is key, and one of the best pieces of advice I can offer on building partnerships. In New Zealand, the Hauraki Goal Forum, which brings together government, iwi, and community groups, as well as young leaders, has shown us how effective collaboration can lead to scalable solutions. By uniting diverse stakeholders, they implemented successful marine reserves and sustainable fishing practices, setting a model that can be replicated across other regions in the Pacific and around the world. New Zealand's youth are stepping up as powerful advocates for our oceans. From the Māori principle of kaitiakitanga, this teaches us the responsibility of being guardians of our natural world, to the Pacific values of Vā Tapuia, which reminds us of the sacred connections between people and our environment. To communities and local groups looking to launch their conservation efforts, it's important to start small, but dream big. Engage youth, tap into our passion and energy, and leverage our voices. Young people like my team and I bring innovative ideas and willingness to challenge the status quo, which can lead to groundbreaking solutions. In Fiji, for example, the youth-led coral gardening project has empowered communities to restore damaged reefs by planting resilient coral species. The project started with a single village and has now expanded to multiple islands, showing the power of local action driven by youth. As we face the twin crisis of climate change and biodiversity loss, it's essential that we continue to amplify the voices of our young people in ocean conservation. In saying that, our generation is not waiting for permission to lead, we're already making waves. In the spirit of ocean optimism, let's invest in our youth, equip us with the tools we need, and trust in our capacity to drive meaningful change. Thank you.
Thank you so much, Joe. And our next speaker is Dr. Kalina Grab. She's a Marine Policy Center Research Associate at Woods Hole Oceanographic Institution.
Thank you, Mariana, for putting together this wonderful panel. I am very excited that this is about ocean optimism, as I think of myself as an optimist. And I'm very honored to follow all three of these lovely panelists. And so hopefully you will see some connections across all of them. I'm going to go through a few different projects that I've been involved in and kind of talk to different innovation, technologies, as well as capacity building efforts. So next slide. So I did my PhD on coral reefs, and I was looking at reactive oxygen species around corals. So we were looking at trying to detect different chemicals around coral reefs that could give us an idea of what their health is without touching the corals. And this research was also involved in an initiative at WHOI called Reef Solutions Initiative. So next slide. And Reef Solutions is an interdisciplinary initiative which entails collaborations across scientists, across the oceanographic disciplines, as well as engineers. Thank you. And so, I think, okay, I thought it was a video. It's not a video. Reef Solutions is a collaboration across the institution, and the idea is that we hope to develop a toolkit so that we're able to detect the health of a coral reef before we can visually see the symptoms. So traditionally, a lot of coral reef health is done visually. You would do surveys, you look at the reef, you can tell by the pigment if it's healthy, if it's diseased. Unfortunately, this is usually too late. It would be as if we would look at our own health visually. So, you wake up each day, do I look healthy? Do I not look healthy? You can imagine that this technique does not buy us enough time to intervene effectively. And so the idea behind Reef Solutions is to create science-based to use scientific techniques to analyze reefs in ways that we can get cues of their health before we visually detect it. The toolkit that they're working on is a science-based intervention, so trying to determine different techniques like Raquel talked on that you could intervene with before the coral is visually unhealthy, as well as autonomous health tracking. So using different technologies to be able to track the health autonomously, because we need to be able to do this at scale, and we need to be able to do it when we are not physically next to the coral as well. And then that can iterate in different ways. So here is a diagram showing some of the different technologies that the interdisciplinary group have been working on. We have autonomous platforms in order to do surveys or measure different aspects. Also, they can collect water samples, reef metabolism, as we heard from Raquel. A lot of the individuals in this group are actually measuring the microbiomes associated with the reef to classify what does a healthy reef microbiome look like and what does an unhealthy reef microbiome look like. They've also developed, they have also been looking at reef acoustics and doing studies where they play back healthy sounds of a reef to see if it can increase settling of larvae. As well as hydrodynamics, so looking at the way that the water is moving around the reefs. And also one that's not shown here is the idea of working on different surfaces that you could settle larvae on. So are there micronutrients that could be added to tiles to increase the settling and to attract coral larvae to certain areas? So the team is working on quite a few different products from these initiatives, including an outline of best practices for collecting microbiomes, as well as talking about different tools that can be used in order to survey. And one thing that I have been inspired by this project to get into is the idea of making technology more accessible. So to engage communities in trying to collect more data. And one way that I have done that is to be involved in this handheld pH sensor called the Fighter. So this is a sensor that can fit in the palm of your hand, and you run it on a cell phone app, and it can be used with very little training, about 1 minute. And I've tested this sensor with a number of different communities, including some students here on the right, where we're on a coral reef in the Florida Keys, and they did reef surveys and collected the water and measured the pH with that. So this is just one example of ways that we can think about making data more prolific and making it more accessible for communities to conduct or to collect. Another initiative I've been involved in is the Global Ocean Acidification Observing Network, or GOON. And GOON's goals are to increase ocean acidification data around the world, to understand the biological impacts of ocean acidification, as well as to increase the modeling inputs. And one initiative they also have a UN Ocean Decade program called OARS, Ocean Acidification Research for Sustainability. And this ties very closely to SDG 14.3.1. And 14.3.1 is an indicator of pH, and it asks to measure pH around the globe at designated areas, so to increase the ability to measure data. And it asks countries to submit their pH data. Unfortunately, there's a large gap between being able to submit that data. There's a lot of things that are needed in order to enable countries to be able to participate and to meet these goals of 14.3.1. So some efforts that I've been involved in with GOON are, they're called GOON in a Box kits. And these pictures here are actually from Suva, Fiji. There's the Pacific Island Ocean Acidification Center, which is also Ambassador Pierre Thompson's home country. And we brought some kits down there, and there have been ongoing trainings for several years in order to train the trainers so that there's a center that is supported internationally but located in Suva, Fiji, and run by scientists and managers from Fiji. And then this center in Fiji can then support all the other Pacific islands. So we brought in over 20 scientists to Suva from different Pacific islands in order to train them on different techniques and to give them these kits so that they could start their own ocean acidification monitoring areas. And this is ongoing currently. Recently, some of the trainers actually just flew up to Hawaii to receive additional training as well. And briefly, one other, so this is how GoOn is structured. There's regional hubs. And last year, there was not a regional hub in the Caribbean. And so we worked with some practitioners in the Caribbean to put out a survey and assess what is the state of ocean acidification monitoring in the Caribbean. And on the bottom left, you can see we got over 59 responses, and on the left, it's almost half of them have received training on ocean acidification. About a quarter have received funding. Some of those have received funding and training, and about a third of them have received neither funding nor training to measure ocean acidification. And when we look at the answers from this survey, we found that receiving funding helped significantly in order to increase OA experience levels, the habitats that they can measure in, the access to equipment, as well as the different types of methods that they can measure. Training also helped, but funding was the big difference in that. So this effort led to community leaders in the Caribbean to form their own GoOn hub, and they actually just hosted their first workshop last week. So. And again, an ongoing effort, but another example of trying to work with the community from the ground up to design what is needed for their own priorities. So I'll leave it with that and excited to talk more in the discussion.
Thank you so much, Kalina, and thank you so much to all the presenters. It's amazing to hear, I think we all know all the threats that ocean and corals are facing, but it's so good, so refreshing to hear some inspiring stories. So from finding a reef that's actually doing well, from developing innovative solutions using probiotics for corals, to developing toolkits and teaching communities on how to use the toolkit, to working with communities in creating capacity development and engaging the youth in coral conservation. We heard some amazing stories here. So now we start our panel. I have a first question. And maybe if you could be brief, so we also have time for people to actually have questions. If you could, in your own story, in your own experience, what enabled this story to happen? If you would find commonalities, what actually enabled this successful story to happen so that other organizations can actually try to find and apply that in their own story.
Hello. Okay. Well, briefly, from my perspective, of course, it's a little different from what, especially Raquel and Kalina presented. I think it's look for reefs in areas that you don't expect them, because actually, not only in Colombia, in other places, we have found reefs, and maybe they will give us some clues of how we can save and restore corals, especially the microbiome, in these reefs, why they're doing so well in places that they shouldn't be. So that would be my.
I think in my case, persistence and a little bit of. I think persistence is the first thing, because when I started thinking about this solution, I was told that was crazy, it was never going to work, and I didn't get any funding. So I had to be creative, and then collaboration is the next one, because then I counted on my collaborators, and I even funded part of the research to prove the concept and move forward. So I think we have to be a bit persistent scientists, because sometimes science is not perceived as feasible or possible, but we have to test. Maybe it's not, but we have to test.
For me, collaboration is definitely an important key aspect, especially working with with scientists. Like all of the data you guys presented gave me so much insight. But being from New Zealand and Fiji and within the Pacific region, a big part of our success is actually intergenerational dialogue. So being able to connect with our elders, being able to notice the patterns and change, especially of coral bleaching and ocean acidification, how our oceans have been warming. It affects biodiversity loss for sure. Like there's fisheries in the Pacific that have depleted. And as you guys know, like the ocean is our source of livelihood. It's where we retrieve a lot of our food and how we gain nutrients. So noticing those patterns and engaging in intergenerational dialogue, especially with our elders and those who came before us, has been a major success in coral.
Yeah, I think for me, I think a lot about collaborations and partnerships. So both within the scientific community, thinking about interdisciplinary collaborations, as well as with communities, and really relying on that indigenous knowledge or the native knowledge of areas. I think that I think that's really powerful, and I love being at COP and hearing this talked about more. I think it's really important, and hopefully we can all take these messages home as well.
Thank you so much. We open for questions. Have a microphone.
Okay, thank you very much for this panel. And, we normally hear lots of doom and gloom, but what is unique about this panel is that you acknowledge the problem, but you say that there are solutions, and I'm particularly pleased with both the collaborative part of it and the technology part of it, and so it's very good. Thank you for hosting this. The question that I have is, of the various positive stories you have, particularly to the colleague from KAUST, I recently had an opportunity to go to Akaba Marine Park. And one of the key things that I noticed was that while the ocean temperature is increasing, the reefs seem to be thriving. And the question is that unique to that area? Or is it more broadly connected with all of the Red Sea? Or what is it, if that is unique to that area, that can be transported to other countries that suffer from coral bleaching?
It's a very good question. I think in some cases, we have some areas in the Red Sea that are actually doing extremely well. We don't know if it's because the degree heating weeks for those specific areas were not actually above the threshold of these corals, or if they actually developed something that made them more resilient. I think it's a little bit of both, but now even in the Red Sea, especially last year and this year, some corals that were considered very resilient, were also hit and they also bleached, and some of them also died. So in the northern Red Sea, we still have some areas that are more preserved and seem to be more resilient, but there is a limit for their resilience, right? So if you keep warming up the planet, even these corals will have to be replaced or will die. So we are trying to learn what they have compared to the rest of the world, because of course they resist temperatures that will be the future of the rest of the world. So we can transfer these resistance, and that includes the microbiomes, the probiotics, the genes and the adaptations. But the corals in the Red Sea will also need protection because the temperature there will also go up.
Yeah, and Rama, you asked if in other areas if it's occurring as well, and I know that there's scientists at Hui, such as Dr. Ann Cohen, who I saw, she's been looking at supercorals in Palau, and in similar ways. And actually, I just saw recently they did their first rapid response mission where they responded to a bleaching event, and within 24 hours flew out there to try and measure and try and collect data on these reefs that are persistent to bleaching.
Thank you. Do you have any more questions? Ambassador Peter.
Yeah, just to Valeria, I mean, that was an amazing presentation. That reef should not exist, as you said. It's in the wrong place and all the wrong conditions and everything. I didn't really fully understand how it does exist. You know, it's got all those negative pressures, but still it's an incredible thing. Please explain a little bit more.
Okay, yeah, so we know some things. We don't know absolutely everything. So we have been studying it since 2016. And as I said, like we have done metagenomics, that is just like kind of going through the microbiome, but as well the DNA to try to find out what had happened. And we have done as well what we know as we have bring corals from other areas to that reef just to see how they survive. And they do much better than in their own reefs. So we know that the nutrients that they're having, like corals, they do feed. Of course, they depend on the zooxanthellae, but when they have the chance, they will take sediments and they will feed. So the sediments that they're getting, it's a lot of nutrients that is helping them. So they grow faster than other corals in other regions. So that is one thing. The other thing is we have these sediments, and it acts, it just prevents the UV light to come into the water, and that protects them as well. The water temperature, it goes high. Actually, we have temperature loggers there, and we know that it can go up to, in normal years, to 33 degrees. That is like way above the usual temperatures. And now is the first time since we started to studying them I started studying them in 2013, actually. It's the first time this year that they have bleach. So water temperatures have go up to 35. So that is the main problem that we're facing. We're trying to understand as well why they have been more resistant than in other areas. So we don't have the full picture, but we keep just studying those.
Thank you. I have time for one more question.
Okay, thank you. My name is Casto from Tanzania, and I've been working with local communities to ensure we have a clean and sustainable ocean. The challenge in Tanzania, majority of local communities, they do not have awareness relating to the, not only science, I can say even a mere knowledge relating to the marine conservation. So I would like to ask you whether we can see a way of empowering local communities, particularly in building their capacity so that they can be more resilient relating to the coral bleach.
Thank you so much for your question. I can relate to that very much because in my village or even in coastal sort of iwi in New Zealand, there's a massive gap between community capacity building, but also community voice and government policy. That's kind of why in New Zealand we have a youth advisory group. So we kind of engage with government, but we're also quite closely tied with our communities, and that way we also provide capacity building programs using sort of, we use indigenous knowledge as a form of storytelling to gather our data to engage more comfortably in our consultation process. But in terms of capacity building, I think that's something that we're still working on. We know the impacts of coral bleaching and the increase in temperature in our oceans, but I think really platforming the voices of our frontline communities and I guess bridging that gap between our communities and government is something that we're currently using right now, which I think has been such a great success because it's implemented a lot of the policies, especially in our emissions reductions plan in New Zealand, bringing our communities' voices and our frontline communities into policy. So, yeah, thank you.
Yeah, and briefly, as I was talking about Go On, one thing that we've found through that network is that so that network has over 1,000 members from 116 different countries. And so the regional hubs that I was mentioning are built by the local communities for the purpose of the local communities. And that's something that we found really important, is to create partnerships with people from that community and let them decide what the priorities are for that, and to have these international partnerships to support what they decide the priorities are. So yeah, hopefully that's one example at least.
One of the things, because we have the same problem in Colombia, we don't have, like the coastal communities, usually they're poor communities, they don't have the knowledge. So what we have done is we created a program that we just go to school and we just advertise and ask like who will be interested in getting some knowledge and getting different things. So we train the students, and they are the leaders that will go out with the fishermen, and we use the fishermen knowledge to know where different reefs are, but they are the ones that actually communicate with everything. So it's training the young ones, and then they will become the leaders in their communities.
Thank you. Yeah, I have also been working in Hawaii for many years, and involving the community is a big part of what we do. Like, we cannot do the science in a silo without talking to the community. So like going to the community first before we do any project, actually, to get their input and update them on every part of their project. So with that, we close our panel, but we're very honored to have the Ambassador Peter Thompson, United Nations Secretary General's Special Envoy for the Ocean, here with us. He's going to give us closing remarks.
Thank you very much. Thank you. Nimble Vinaka Joe. Nice to have my kaiwata here from Fiji. Yawana Nomiyanan. You know, today's my birthday. Happy birthday. Hey, I mentioned that for two reasons. One, I was born in Suva, Fiji, back in the dark ages on this day. And in my hometown, when you go to bed at night on a still night, it is the sound of the waves on the coral reefs that puts you to sleep. I just can't imagine a world without coral reefs, but you know, that's what we're here to talk about. The other reason that this date that I mentioned, 18th of November, is that back in 1992 on the 18th of November, so that was, 32 years ago, 1,600 scientists from 71 countries around the world got together and they signed this warning to humanity, right? And they released it, as I say, on the 18th of November. Half of those scientists were Nobel Prize winners. So, I mean, I think you could say it was probably the top gathering of scientists at the time. And this is what they said to us all. Human beings and the natural world are on a collision course. Human activities inflict harsh and often irreversible damage on the environment and on critical resources. If not checked, many of our current practices put at risk the future that we wish for human society and the plant and animal kingdoms, and may so alter the living world that it will be unable to sustain life in the manner that we know. Fundamental changes are urgent if we are to avoid the collision that our present course will bring about. No more than a few decades remain before the chance to avert the threats we now confront will be lost, and the prospects for humanity immeasurably diminished. We, the undersigned, senior members of the world's scientific community, hereby warn all humanity of what lies ahead. A great change of stewardship of the earth and life on it is required if vast human misery is to be avoided and our global hope on this home on this planet is not irretrievably mutilated. So I think you can say that we were duly warned 30 years ago. And just one other quote I wanted to give you, because it was something that I read well before the Paris Agreement and the SDGs. And this was from Sir Martin Rees in a book that he wrote. He was the Astronomer Royal of the United Kingdom at the time, the top scientist in the UK. He said, if we could agree as a species what we wanted, where we were headed and why, then we would make our future much less dangerous. we might understand that which we can and should relinquish. It's a very big word, relinquish, actually. Now, as I say, that was pre-Paris Climate Agreement, and it was pre the 2030 Sustainable Development Agenda that the UN adopted. And that was, our agreement on maybe not so much what we should relinquish, but how we should shape our society on this planet. So how did we do? We're failing on both counts. If you've read the UNEP emissions report that came out recently, you'll see that we're well behind in terms of the Paris Climate Agreement's aims. And the Secretary General of the United Nations, on reading that report, said that unless our global leaders, and he was referring to the leaders of the top 8 economies in the world, unless they close that emissions gap, we are plunging headlong into climate disaster. Not climate crisis, climate disaster. If you've read the WMO 2024 report, you'll see that we're heading in absolutely the wrong direction in terms of climate. We have surpassed 1.5 degrees global warming this year. That's WMO. The acceleration of glacier melt. Given. And I personally, not just after hearing this panel, but I personally don't believe that coral will be extinguished. Certainly not in my lifetime, hopefully not in my grandchildren's lifetime. But I just can't imagine a world without coral. And hearing the sort of things we did from this excellent panel today does give me time. There's a sign at the back saying wrap it up. I've got about another 20 minutes that I need to speak to you about, but so I will wrap it up. Look, I often say that we've come from caveman days to space age just in a blink of an eye in terms of planetary life cycle. But why did we do that? It was basically because we had the genius of innovation and the genius of sharing. And the sort of things that we are hearing today, you can see the hints of that genius, hints of that sharing. And that's how we're going to get there, folks. We have to make these interventions that we all know about on coral's behalf, because it's really hard to imagine that you can have a healthy planet without coral, right? Because you can't have a healthy planet without a healthy ocean. And how can you have a healthy ocean if there's no coral in it? There's 25% of the ocean's biodiversity relates to coral. So just think it through logically, and coral and a healthy planet, and therefore our survival, are just directly linked. So I think we are awake to this now. There will be at the UN Ocean Conference in June next year a pledging event for the Global Fund for Coral Reefs. There is big hopes for that. They're looking at trying to put together about $12 billion worth of investments from public and private sources to conserve at least 50% of the coral reefs of the world. I myself would like to see all coral reefs put within that 30 by 30 target that we've set ourselves. And I think here in this room at 1:30 we're going to be talking about that 30 by 30 target. So look forward to that. I'll leave you with a mantra, because you rightly pointing us in the direction of hope. So the mantra is hope in progress, faith in reason, and inspiration in nature. And coral is probably the most inspiring thing I know about in nature. Thank you.
Thank you all for joining our panel and joining our session. I invite all the panelists and Ambassador Peter to take a family photo.